So now we've been able to run through some jobs successfully. One of the key aspects of the framework is that it's able to deal with different types of exceptions. If we look at our main process, we can see that in the process transaction state, there's a try-catch handler. What this means is that if there's a business rule exception, and by business rule we mean any predefined business logic that is part of our process, so for example, if an email address doesn't contain an @ sign, or if a name isn't of a sufficient length, we can deliberately throw a business rule exception and it will be handled by the state machine. The state machine will then process the next case without taking any further action. However, if there's a system exception, such as the Acme application isn't available anymore or the selectors can't be found for whatever reason, then the state machine will restart the Acme application and attempt to process the work ID one more time. In our case initially, all of our cases were successful because we didn't have any criteria to throw exceptions. So what we're going to do temporarily is add in an if statement just to see how the state machine deals with these different types of exceptions. What we're going to say is if the work ID contains a 1 or a 3, then we're going to throw it as a system exception. If it contains a 2 or a 4, then we're going to throw it as a business exception, else we'll mark it as a successful case. So let's use the contains function and place a 1 in the brackets, or if the work ID contains a 3, then we're going to throw a system exception. The exception message can say we'll throw a new exception. The ID contains a 1 or a 3. And note that in the syntax, the 1 and the 3 are in quotes. That's because the object type is string, not integer. If it's not 1 or 3, we'll throw a second if statement. We'll copy the syntax and make some small changes. Make it 2 and 4 instead. This time, rather than throwing a system exception, we're going to throw a business exception. New business rule exception. And this time we'll say the work ID contains a 2 or a 4. We don't need anything in the right-hand side because if the case processes without throwing an exception, it will be deemed automatically to be a success. Let's make sure the Acme application is closed down. So one thing that we need to do is make sure that we re-add our data items to the queue. This is because when we previously ran the cases, everything was consumed and there are no outstanding items waiting to be processed. To do that, make sure that we're on the work items page and run the data load process again. If we go into Orchestrator, we can see that there are some new items waiting to be processed. Let's make sure Acme Academy is closed down, rerun our main workflow, and check what the outputs are. So you can see that item contained a 1, and the reframer has automatically closed down the application and is going to restart it. Because there was a 1 in the work ID, it was seen as a system exception and was handled accordingly. This time there's a 2. So here's an example where there's a 2 and a 4, so it would be marked as a business exception. Obviously, you don't need to go through each case. You get the idea that each exception is being handled slightly differently. So eventually, you'll see that the robot terminates and finishes, having worked through all of the items. It took a little bit longer than we would have hoped. We probably should have only used a single number during the process. However, what we would have seen is that the system exceptions retried, business exceptions didn't retry, and the successful cases also didn't retry. If we quickly look at Orchestrator to see what the results were, we can see that there are a number of failed cases and a number of successful ones as well. If we look in a bit more detail, we can see that there was an exception, and the reason for the exception is that the ID contains a 1 or a 3. For the successful case, we can look at view details, and we don't have an exception message. Finally, the other type of exception is a business exception, which we can see here. If we view details, we can see that it was a business exception thrown, and the reason was that the work ID contained a 2 or a 4. So that's how the framework handles the various types of exceptions and restarts applications as and when required. Now that we've had a quick look at how the framework handles the different types of exceptions, let's go ahead and try running our process for real. We're going to delete this if statement because we don't need it. Rather than delete the message box, we're going to create a log message as well, just to say that this particular work item is being processed. Take the syntax, copy it into a log message, and delete the message box. Uncomment out the process that we commented out earlier. And let's just check the arguments that we're passing into the process. So in this case, we don't need to pass in the WID text. We're going to pass in the transaction item. And we're also passing in the config dictionary. However, we need to make sure that the WID that is contained within the transaction item is passed successfully into each of the relevant components. Let's go into our process workflow and make sure that it's being used correctly. We know that the WID is used within the navigate to work items workflow. So let's go and amend it. We can see that it's hard-coded at present, so instead we're going to replace it with the specific content, which contains our WID. But one small change is that the transaction item is actually in transaction item because it's an argument coming into the process that's been passed through from the state machine. If you're not sure where else that code might have been used, you can use the search function and search for WID. Have a quick look through to see if it's used in any places that we need to change. Additionally, let's check all of the other invoke workflows just to make sure there's no hard-coded values being passed through. Okay. Remember that we've used the SHA1 website URL information that we placed into our config file previously. And everything else looks good. Let's give the process a run. At the moment, we currently have our system applications retrying. This is going to take a long time whilst we're testing. So unfortunately, we're not able to amend the queue once it's been created. So let's go and delete the queue and recreate it. This is as simple as clicking delete on the queue name, pressing yes, creating a new queue, the same name, and setting auto retry to no. Now let's go and see whether our process runs successfully all the way through. Check that the Acme Academy is closed. And one thing to note actually is even if the Acme Academy isn't closed, one of the features of the framework is that it will close down any applications that are open as soon as it starts running. Prior to running, because we deleted the queue, we need to go and pre-populate it using our data load process. Let's open up the Acme Academy, back to work items. Now let's close the Acme Academy down. And let's run our process for the first time. Typically when running a process, it's always good to start with a clean screen, having closed down all of the applications. However, the framework does close down the applications as part of the state machine. Here we can see we're working through each of the items, all being added into the SHA1 online website. Work items are being updated with a comment and a new status. You can see that each time the SHA1 website is opened and closed. And most of them seem to be working successfully. And once the robot's finished running, it logs out of the application, closes everything down, and we're returned back to UiPath Studio.